In our second video for section 10.7, we're going to talk about special right triangles. We just talked about Pythagorean theorem, which is when we have a right triangle and we know two of the sides, we should be able to find the third side by using Pythagorean theorem, a squared plus b squared equals c squared. But on a special right triangle, that means I have a 45-45-90 triangle or a 30-60-90 triangle. I really only need to know one side and I should be able to find all other sides of the triangle. There happens to be a special relationship between the sides and the angles of a 45-45-90 and a 30-60-90 triangle that work all the time. Kind of cool. That way we don't have to use the Pythagorean theorem all the way through, or we can find all the sides even if we only know one. I found a cool Khan Academy video that shows you why these two theorems work. They've kind of proven it for you and showed why they work. In this video, we're just going to go ahead and apply them. Now, we have special formulas that work anytime we have a 45-45-90 triangle. 45-45-90, meaning one of the angles is 45, the other angle is 45, and then we have that right angle, the 90. On a 45-45-90 triangle, you notice that the two angles are the same. That means the two sides opposite of those angles are also the same. So we have an isosceles right triangle, where I have two sides being the same. If one of the sides, or legs, is x, then that means the other leg would be x, right? And if you were to work this out and you use Pythagorean theorem, a squared plus b squared equals c squared, you would always get the relation that the hypotenuse then is x times the square root of 2. So if one of the sides, or legs, let's say is 3, then that means this leg is going to be 3, and then that means my hypotenuse is going to be 3 rad 2. It works all the time, anytime you have a 45-45-90. Let's do another one. Maybe I said that one of the legs was, 9. If this leg down here was 9, that means my other leg would be 9 because they're the same. And then that means my hypotenuse would be 9 rad 2. Pretty cool, huh? Very quick. We don't have to use Pythagorean theorem because we already know those relationships. So it's important that you memorize what those relationships are. Again, across from the 45 is x, across from the other 45 is x, and across from the 90, the hypotenuse, is always going to be x times rad 2. All right, there's also a special relationship between a 30-60-90 triangle and its sides. On a 30-60-90, across from the 30-degree angle, let's call that x. Across from the 90-degree angle, we have 2 times x, double that. And across from the 60, we have x rad 3. The relationship is always that. So I would make sure that you memorize it from what relationship or what ratio we have on our sides compared to where our angles are, not in order. Because if I were to take this triangle and maybe rotate it, flip it around, try not to memorize it in like clockwise or counterclockwise direction because it might be switched around. I always remember it as the side across my 30 is always x, the side across my 90 is always 2 times x, and the side across my 60 is always x rad 3. So if I give you any one of these sides, you should be able to find me the other two sides by knowing this relationship. So let's say the side across from the 30 was, 4. If this leg was 4, then that would mean the hypotenuse is 2 times 4, or 8. If x is 4, then I would say that the side across from the 60-degree angle is 4 rad 3. I can find all sides very quickly without having to use Pythagorean theorem with only knowing one side because we know these relationships. Let's do one more real quick and then we'll do some other examples. Let's say that we knew the hypotenuse was, 10. Well, if the hypotenuse is 10, and I know that the hypotenuse is supposed to be 2 times what the other leg is, the leg across from the 30, well, could I take this equation, divide by 2, take half of it, and figure out what x equals? If I divide both sides by 2, then I end up getting x equals 5, right? Well, if x equals 5, then that means this leg is 5, and this leg is 5 rad 3. Pretty quick, right? Make sure you know those relationships so that you can find all sides of the triangle, even if you only know one. As long as it's a 30-60-90, you can always apply those relationships. All right, let's look at example 3 and 4 real quick. On example number 3, it says one leg of an isosceles right triangle. Isosceles right triangle measures 7 centimeters. Find the length of the hypotenuse. Give your answer in exact form and an approximation of 3 decimal places. So it says here we have an isosceles right triangle. That means one of the angles is 90, and isosceles means I have two sides that are the same. Well, if two sides are the same, then that means two angles are the same, so those angles must be 45 and 45. So my picture looks something like this. And as soon as I know that I have a 45, 45, 90, I know certain relationships, right? I know that across from the 45 is x, across from the other 45 is x, and across from the 90 is x rad 2. It says in my question that one of the legs is 7 centimeters, so I know that that's one of the sides across from my 45. If one of them is 7 centimeters, then that means the other one also has to be 7 centimeters because they're the same. If each of those are 7, and if I use my relationship that this side is x, and my hypotenuse is x rad 2, well, that would mean very quickly that my hypotenuse then is 7 rad 2 centimeters. So in exact form, I can quickly say that my hypotenuse is 7 times the square root of 2 centimeters long. Or using my calculator, I can do 7 times the square root of 2 and say that the hypotenuse is approximately 9.899 centimeters long, without having to do Pythagorean theorem, without having to do very much work at all, really, just because I know those relationships and that special right triangle. Let's do one more, number 4. Example number 4 says the hypotenuse of an isosceles right triangle. So again, we have an isosceles right triangle, a 90 degree and then two 45 degrees because the two sides are the same. The hypotenuse this time is 5 feet long. All right, let's label that. Find the length of the two legs. Give an exact answer and then a decimal to 3 places. So the relationship on a 45, 45, 90. This side is x, the other side is x, or leg is x, I should say, and the hypotenuse is always x rad 2. This time, we don't know what the two legs are. We only know what the hypotenuse is. And it might be a little bit harder to tell right away what x is. But I do have an equation that says that this side, the 5, should be equal or have a ratio of x times rad 2. So I can set up an equation that actually says that exact thing, that 5 should equal x times rad 2. And now I can take that equation and solve for x. I can try to get x by itself by dividing both sides by the square root of 2. When I do that, the square root of 2 divided by square root of 2 is 1, so I get a 1x, or x, on that right side. On the other side, I end up getting 5 over rad 2. So x equals 5 over rad 2. But let's go ahead and rationalize that denominator, because we don't like to see those radicals in the denominator. We've talked about rationalizing before, where we can multiply both the numerator and the denominator by that radical to get rid of the radical in the denominator. On my numerator, I have 5 times rad 2. On my denominator, I have rad 2 times rad 2, which is the square root of 4, or we could say just 2. So I can say that x equals 5 rad 2 over 2. Well, if x equals 5 rad 2 over 2, and the leg is also x, then that means each of the legs is also 5 rad 2 over 2 feet long. That would be the exact value, or I can punch it in my calculator, 5 times the square root of 2 divided by 2, and I ended up getting 3.536 feet. Make sure you know those relationships. Make sure you memorize those. That'll make it much easier for you to solve these types of problems when you're only given one side, as long as you know it's one of those 45, 45, 90 triangles. We'll do some examples of a 30